Hello, we are the group number 2 and we're gonna talk about the operating characteristic of a star-star and star-delta connection in a three-phase transformer. These are the members of the group. I am Emilio Moreno and I'm gonna start with a little introduction of what is a star-star connection. So, this type of connection of a three-phase transformer is used for two systems of relatively high voltages and low powers, and that is because the insulation capacity is limited. These type of transformers are very effective because there is no gap between the respective primary and secondary voltages. Besides this, these transformers have the particularity of having a neutral in the primary and the secondary as a safe manner security. Okay, so for the connection of this transformer, we have to know first of all that this type of connection and star-star connection is used whenever there is an efficient way of communication between the neutral of the weldings and the neutral of the source. If there is no that case, the presence of distortion in the input tension will be very observable. So, uh, an star connection is made by joining all the points of negative polarity or non-polarity of the three coils, both the primary and secondary windings, to a common node that connects to the source neutral for the primary, and each line feeds each coil of the primary winding respectively at each point of positive polarity. This only in a polarity on a subtractive polarity three-phase transformer. Thank you.
I'm Carolina and I'm going to talk you about a three-phase transformer with a star and star connection. As we can see in the picture, the voltage between any line of the three-phase transformer is called line voltage, and the voltage between any line and the neutral point is called phase voltage. As we can see, this is the line voltage and this will be the phase voltage. Know that the secondary current in each phase of a star-connected group of a transformer is the same as for the line current of the supply. As we can see here, the phase current is the same as the line current. And also we can see here a summarized of the different values of voltage and current for the transformer with a star-star connection.
The disadvantage about connection star-stars. If the load in the transformer circuit are not balanced, which is the common, then the voltage in the phases can become severely unbalanced. Negative naturals are very unstable unless they are solidly connected to a ground.
Hi, my name is Brian Contreras. I'm going to talk about connection star triangle. As we can see the image, we have three transformer monophasic. In the primary connect in star and the secondary in the connection is the triangle. This type connection is more stable with respect to unbalanced load because any imbalance that arises in the particular is the redistribution. The secondary voltage moves 13 degrees with respect to the primary voltage of the transformer. This type connection has neutral in the primary. It can cause problems in the parallel setting of the secondary of the two transformer bands. Thank you.
Good afternoon guys, my name is Johnson. The star and triangle connection, operating characteristics. If the three-phase trafo is connected in a star and mesh, each star connected in primary wiring will receive the phase primary voltage equal line to line voltage divide square root of 3, knowing phase to line primary voltage is phase to neutral voltage and line to line voltage is VL to line voltage. Second point, the star and mesh triangle transfer ratio equal number of primary windings divide to secondary windings per square root of 3. Like the picture, show the picture. Line to line voltage 7,200 and line to neutral point 4,160. That is what 240 line to line secondary voltage equal 7,200 line to line primary voltage divide square root of 3 per turns ratio. And finally, we have turns ratio equal 17.32. The phase to neutral voltage in primary equals 7,200 line to line primary voltage divide the square root of 3 equal 4,160. The 3 point is the primary remains stable due to the triangle in secondary, and the 4 point is in case you have unbalanced load in triangle, redistribute temporarily the current. Thank you very much.
My name is Eduardo Ceballos and I'm going to talk about the disadvantage of the connection. One disadvantage is that the secondary voltage shifts in delay 30 degrees with respect to the primary voltage, which can be a problem if we wanted to connect in parallel because it's a request that there's no delay between the primary and the second voltage of the transformer. Another disadvantage is that a neutral cannot be available to connect to the ground or for a forward distribution unless an auxiliary device is available. One problem in one phase means that the three-phase unit cannot work until it is repaired. The winding in the delta can be mechanically weak in the case of an elevator transformer with a high secondary voltage. It means that it's not recommended to use it as an elevator transformer if it's going to transform to a very high voltage. Thanks.